Okay, so at the top of that sheet are the trig ratios, sine, cos, and tan. So they are there, they're on your formula sheet. I gave you a copy of that. Refer to it, memorize it, okay? If you want to use that abbreviation, then you're welcome to. Somehow, you have to use them appropriately, right? In the right situation. I will give you a formula sheet on your tests, so you will always have that. Ron, quiet please. Okay, so finding an angle, that's what we're going to do first. And we started learning how to do that on using our calculator yesterday. Okay, so what we need in order to find an unknown triangle is if we know two angles, we can obviously subtract them from 180 to get the missing angle. If it's a right triangle, then we already know one of them is 90. So we could just subtract one of them from 90. That's what the remaining two have to add to. If we don't know that, two angles, then the other situation is if we know two sides, because we've learned trig now. So it says label the sides you know relative to the angle you are looking for, then set up the primary trig ratio based on the two known sides. Remember, to find the angle, you must use the inverse of the trig ratio. So your second key or shift key on your calculator. So in question 1, it says determine the indicated angle to the nearest degree. And just a reminder that diagrams aren't necessarily to scale here, okay? So taking a look at this angle, this side that's touching it, this leg, is adjacent. So I'm just going to label that. This one is the hypotenuse, okay? I don't care about the one that's not labeled. So I have the adjacent, I have the hypotenuse. You look at your trig ratios, there's adjacent over hypotenuse, which is cosine. So I'm going to set up my ratio, okay? Cos always has to have an angle with it. You can't just say cos equals. Then it's just 3 letters. It's not a variable, it's just, I don't know, some random thing that you're writing down. It has no meaning. So you need cos theta in this case, because we don't know what the angle is, equals 5.3 over 17.9. Okay? Do not divide it. Do not get the decimal form. Okay? It's not your final answer. Your calculator is going to do things for you. So now theta, remember, if we're finding the angle, it's going to look like cos with a little negative 1, which means cos inverse, bracket 5.3 divided by 17.9. So that's what you enter in your calculator. So if I do it on a TI, I'm just going to try to clear off some of this stuff. So I'm going to go second key, cos key, 5.3 divide 17.9. Never, ever, ever get the decimal form of that fraction, unless it's a terminating decimal, because then you're changing the value. Okay? You don't. You just do that. You do not need to find the value of that ratio. And so now, if it says to the nearest degree, that would be 73 degrees. Okay. Don't forget the degree symbol. So what I would want to see in terms of a written response work would be either one of these. You don't have to show both, but either this setup or this. You can show both, that's even better, but one or the other, okay? And then the answer. So don't just give me the answer if it's in written response. I want to see what you're substituting in, okay? So next one, there's my angle. So this 10.4 is adjacent, and opposite is the 15.1. So now I want something that has opposite and adjacent, no hypotenuse. So that would be tan. So tan of theta. So theta is a Greek symbol, theta, and it's often used for angles. Okay, so that's why you can see it there. It's kind of a zero with a swoop through it. And tan theta in this case is opposite over adjacent. So when I'm calculating, it's going to be tan inverse of 15.1 over 10.4. Again, don't find that ratio. Just substitute it into your calculator. So I'm going to do this one on the Casio. Just a sec here. Okay, so this is going to be, I need to be on, oops, it's not a touch screen. So shift key, tan key. Remember, I need brackets. It doesn't automatically open on my version of the Casio. 15.1 divided by 10.4. Close the brackets, enter, and to the nearest degree is 55. It needs to be in degree mode. Yep.
How do we know, like the theta in there? How do we know that, like, which
Well, you have to label, so you have to identify which sides are given to you. So the 10.4 touches theta, and it's not the hypotenuse, so that's the adjacent. So you label it. Then 15.1 doesn't touch theta, so it's the opposite. So if you have opposite and adjacent, you have to use whichever trig ratio has opposite and adjacent. Correct. Well, those sides that are given to you are relative to that angle. You have to know where that angle is. You can't just label anything adjacent.
Well, I know that, but like you can do with the hypotenuse and the opposite.
Not in this case. We don't have the hypotenuse. You would have to calculate it. Oh yeah, if you have the hypotenuse, yeah.
It's just the two numbers that agree.
Correct. Any one of those. Yeah. Okay, so then this one here, this is the hypotenuse that's given to you. It's the side opposite the 90. And then the 135 is touching theta, so that's adjacent. Okay, so adjacent and hypotenuse, if you look back up at your list here, adjacent and hypotenuse, again, is cosine. So we should have done a sign, but whatever. So cos of theta is adjacent over hypotenuse. Always check, make sure the units are the same. So if one side is measured in meters and one in centimeters, you've got to change them to be the same unit. Okay, but in this case they are. You don't have to reduce that fraction, right? You could, 5 goes into everything, but don't spend the time. That is not the answer, right? We're not looking for a reduced value of the ratio. That's a separate question. This is just finding the angle theta. So now I'll go back to my TI and I'll do second cos 185 divided by 200. Okay, and that is 22 degrees. Oh, is it? Let me erase that. Yeah, I covered it up. Oh, it is 135. Okay, sorry about that. So let's fix this number here. Okay. Okay, so here's, if you have a TI, here's something you can, oops, I'll show you a trick. In your TI, you can go up to the first calculation that I had, copy it out, so enter on it, so it copies it, and then cursor backwards and change that to 135. You don't have to enter it all again. And I think also on Casio's the same thing happens. So now it's actually 48 degrees. Well, it's 135 over that, and that's 48 degrees. So now we're going to find a side length. So that the last one, we had to have two sides in a right triangle, and we could find an angle. Now to find a missing side, if we know two sides, we can just use the Pythagorean theorem, right? That you've been doing for a couple of years. But you might not know two sides. You might only know one side. And so if you know one side in a 90-degree angle, if you know another angle, one of the acute angles, you can find a missing side. So you need to know an angle and a side in a 90-degree, which means basically you need to know two angles and a side. Okay, so label the side length you have and the side length you're looking for in reference to the angle that's given. Then use the primary trig ratios to solve for the unknown side. So taking a look here, here's your angle you know. 5 is adjacent. B is opposite. The hypotenuse we don't know and we don't care. Okay. So anything that uses opposite and adjacent, remember, is tan. So tan of 27 degrees, so now I'm putting in the value because I know that angle, equals the opposite, which is B, over 5.0, or just 5. Okay, so now our unknown, we have to solve for this B. Well, the opposite of dividing is multiplying both sides. So those divide out. You don't have to show that step. You'll be doing so many of these that you'll get to the point where you'll set up your ratio, and then you'll go B equals 5.0 tan of 27 degrees. So again, in terms of work on a written response test, I need to either see this setup, tan of 27 equals B over 5, or this one, not just the final answer. Okay, but not both. I'm okay with one or the other. And then in your calculator, what I'll use the Casio this time. Now 5.0, I don't need to show that. I can just go 5. It's the same. And then times tan of 20. Oops, I meant tan of 20. Delete the 3. Oh. Okay, let me start again. Okay, so 5 times tan of 27. Now you can put brackets, but you don't have to. In a TI, the brackets will open for you. It would only be if you're multiplying afterwards that you would have to have the brackets. But now that's 2 nearest tenth is 2.5. And whatever units the other side was in. So if it was in centimeters, then you need to use centimeters. Okay. Makes sense in that diagram. They're not to scale, but with 27 degrees, that's a pretty small angle. And so the opposite side should be smaller than the adjacent side. Okay, next one, we have angle Q. Notice the labeling. It's really important to know the labeling on a triangle. I think we talked about this, but vertices are capital letters. Sides opposite are lowercase of the same letter. So side opposite angle B is lowercase b. Side opposite capital C, this would be lowercase c. Side opposite A would be lowercase a. Okay, so if you're not sure, use that method. So here, compared to Q, this is the hypotenuse. It's the longest side. It's opposite the 90 degrees. And N touches angle Q, so that's adjacent. So adjacent and hypotenuse, that's cosine. So cos of 65 degrees is the adjacent, which is n, over 10.0. And again, you don't have to put the 0.0 really, because it's the same as 10 when you calculate it. So unknowns in the numerator, n is going to be 10 cos 65. And enter that in your calculator. I'll go back to my TI, and I'm going to enter 10 cos 65. You don't even have to use the multiplication symbol. Okay, so you can just put 10 cos 65. Notice how I'm not pressing the second key or the shift key, because I'm calculating a side. I only press that button if I'm doing the angle. Okay, and this is 4.2. And that'll be centimeters. Okay, if it's a leg that you're looking for, then it has to be shorter than the hypotenuse. So 4.2 is shorter than 10, so you know at least that you're in the right ballpark. Might not be, maybe you did something else incorrectly, but certainly at least makes sense. Okay. Take a look here. Opposite angle Q is lowercase q. Okay, that is the hypotenuse. Okay, the angle that we're given is 15. So 1.5 is opposite. It's not forming that 15 degrees. So this is opposite. Okay, so opposite and hypotenuse is sine. So sine of 15 degrees is 1.5 over q. Take a look where q is. Q is in the denominator. So different from the last two. So in order to get q out of the denominator, you can think about cross multiplying. Put this over 1. And so when we do that, cross product, we will get q times sine of 15 equals 1.5. Okay, because 1 times anything is 1.5. Now to get q by itself now, we have to divide by sine of 15. So those divide out. So really, our calculation is 1.5 divided by sine of 15. You do not have to show all of that work. So you can either show the beginning, just like the others, and then the answer, okay? Or you can show this. So either one of those circle. You don't have to show all the work in between. Here's a hint to remember when you divide as opposed to when you multiply. Take a look at the setup. I always do the setup first. What is sine of 15 degrees, or what is tan of 30 degrees, or whatever it is? If the unknown is in the denominator, then I divide. So denominator starts with a D, divide starts with a D. So if my unknown's in the denominator, then I'm dividing by the trig ratio. Not the other way around, not the trig ratio divided by 1.5. This was the other side multiplied by the trig ratio. This is the other side divided by the trig ratio. Okay, denominator, divide. Memorize it if you need to. Okay, so now in my calculator, do the Casio this time. So I'll go 1.5 divided by, oh, always doubles up. Okay, divided by sine. I'm going to put brackets in this one just because it's in the denominator. I just want to be safe. Do that. Oh, it needs brackets in the whole thing. I'm not sure about your version. This is a different version of the Casio, so I need, oh, just a sec. Oh no, it was good. Okay, so look at what happened to mine. So I just used brackets around the angle, but look at that funny answer. Okay, so in a Casio, if it's not in test mode, it's going to give you an exact value. And that's why you can't use your calculator on a test without it being in test mode. Remember that unit where we were simplifying radicals? Well, Casios will do it all for you. And so it has to be in the proper mode. And so here, if on a day-to-day basis, you are calculating, and we want decimal form anyway, you look for the button that has an arrow to D, okay? Sometimes it's S arrow D. This one is F fraction to decimal, I think it means. In any case, it will convert that to decimal form. So 5.8 is the answer. And then whatever units we are dealing with here, which is centimeters. Okay. Pause. So to solve a right triangle, you find all the sides and all the angles. You need to be given A is a right triangle, obviously, and then either two sides or a side and an angle. Okay. If you've been given two sides, you can use trig to find an angle, then subtract from 180 to find the other angle, or actually just from 90 makes it even faster. If you're given a 90-degree triangle with a side and an angle, you can use trig to find one of the other sides. Use trig again or Pythagorean theorem to find the third side. And obviously there we can just subtract. We can get the other angle really easily here, right? Angles in a triangle add up to 180. This is already 90. So these two add up to 90. So that's 50, right? So that's an easy calculation on that one. So we are going to do the first one in that chart. We've copied it out here. Okay. So this one here has two sides. And the first thing that you do might be different from the first thing that I do. Okay, I'm going to use the Pythagorean theorem to find this missing side here. I'm going to label it lowercase a because it's opposite of capital A. So I'm finding a leg of that triangle. So a squared equals the hypotenuse squared minus the other leg squared. So 19 squared minus 14 squared. So 19 squared minus 14 squared is 165. So A is the root of 165. And then, so the square root of that answer is 12.8. Now, I'm going to show more decimal places. It says to round to the nearest tenth, but in case I use that calculation somewhere else, I'm going to write 845. So 12.845. And then I will show it as 12.8. I'll probably summarize in a little chart all the values. Okay, now to get angle A, I have two angles there, two sides. So compared, if I'm looking for this angle, this is adjacent and this is hypotenuse. Okay, so adjacent and hypotenuse is cosine. Okay, so cosine of A is 14 over 19. So A equals inverse cos of 14 divided by 19. Okay, and then, okay, I'll use a Casio this time. So shift cos 14. Oh, I'm going to need brackets. I forgot. So bracket 14 divided by 19. Close bracket. Oh, doubled up again. Nuts. Okay, so shift cos. Remove my pen. 14 divided by 19. Okay, there we go. 42.537. Okay, degrees. Now, that rounds to 42.5 degrees. Now, you could use trig to find angle C, but a little bit faster than that is just subtracting from 90. So 90 degrees minus 42. Now, I'm going to use the one where I kept a few decimal places. In this case, it's not going to matter. If I used 42.5, we're still good. But if you had, say you had a different polygon for some reason, you wouldn't be using trig, but you were calculating the angles and you had different rounded ones. You had to, say, subtract 3 angles and they were all rounded values. Then you want to keep more decimal places. So I always keep a few extra decimal places and then round at the end. So in this case, it's going to be what? 47.5. Okay. So I'm going to summarize up here. So angle A is 42.5 degrees. Angle C is 47.5. They should add to 90, right? Which they do. And then lowercase a is 12.8 centimeters. So there's a difference between a capital letter and a lowercase. Some of you get a little bit lazy in math with that, but you can't. There's a difference. Okay, in question 4, it says solve triangle PQR. Well, you don't have a triangle PQR. That means you're going to need to draw it. Okay, and so in drawing a triangle, these are all 90-degree triangles. So notice that the 90 degree is Q. So use a straight edge. I'm not going to just because my computer takes so long. So this would be your 90, and I would label that Q. If I make one leg longer than the other, okay, and then join up Okay, and now it says angle P is 35. So I'm going to choose the smaller of the two angles. So this one I would make 35. Okay, and that is angle P. And it's called angle P, triangle PQR. So this would have to be Q. Oh no, sorry, R. That would have to be R. Okay. So this measurement is the side opposite capital R. And so that will be 85 inches. All right, so the last question we did had two sides. This one has one side and one angle. Okay, so I'm going to maybe make this just a little degree single, a little smaller. Okay, so looking at this side over here would be lowercase p. So if I label this, 85 is adjacent to capital P, and this would be opposite capital P. So opposite and adjacent is tan. So tan of 35 is lowercase p over 85. Okay, so when I solve for p, guys, stop please. That would be 85 tan of 35 degrees. Okay, so enter that into your calculator. And that will be your side P, the other leg of the triangle. So 59.518, 59.518, which to the nearest tenth is 59.5, but I show both of them, okay, because if you decided to use the Pythagorean theorem now, you would have to get the hypotenuse. You would not want to use the rounded version. You would want to actually use all decimal places. So in this case, I'll show you what happens. I'm not going to write it down because that's not the method I would choose. But if you did, I would take that side, 59.517, I would square that right now. So it squares that answer. Add 85 squared. And then that's the number that you take the root of. So you can copy it out or do the answer. And that would give you the hypotenuse. Okay? Let me show you, if I rounded it and just used 59.5, okay, I would get, it would be, actually, to one decimal place, it would be the same, but to two decimal places, it would be off, okay? So you want to keep those decimal places. Now, saying that, I'm not going to use Pythagorean theorem. I'm going to use this angle again, this adjacent side again, and I'm going to find the hypotenuse, which is the opposite side. So I'm going to call it Q, which is the opposite side. Okay, so if I have adjacent and I want the opposite, that is cosine. So cosine of 35 is 85 over Q. Now I'm not using any rounded numbers. Okay, and so my unknown's in the denominator, so I want to divide. Okay, let's compare to that last answer that I used the Pythagorean theorem to get. So now, if I go 85 divided by cos of 35, I get the same answer as the unrounded at the top. Okay, so now to one decimal place, that's 103.8. And that is inches. Now, the only other thing we need is the angle R. No trig needed because we have two of the angles. So angle R is going to be 90 minus 35, which is 55. Okay. So I'm just going to summarize, and I'm going to in a little box. So R is 55 degrees. Lowercase p is 59.5 inches. Lowercase q is 103.8 inches. Remember, the hypotenuse has to be the longest side. So it's got to make sense, and it does. Okay. And so that's the lesson, calculating angles and